Welcome, this is Professor Bright, and we're going to start a new video series talking about the unit circle. One quick reminder before we get too far into the video for right now. At the beginning of all of our lessons, there are these learning targets, learning steps, and then also video lists. But really, when we write exams and other assessments, we are looking at these things, and we're saying, can we make sure that the students can communicate this information to us somehow? So we're designing questions based on these. So keep that in mind as you study. Now on to the topic at hand. We are going to talk about the unit circle, and perhaps you already know about this, or you could probably put two and two together. Okay, it's a circle, unit length, or unit radius, right? Okay, sure. Still important because there is a bit of language that we develop in here talking about the trigonometric points. So we talked about angles. Yes, good. Angles, degrees, radians, all the things. Okay. When we look at our study of trigonometry, because we're building up to that, right? We focus on one circle over and over and over and over, and that is the unit circle. Okay. I'm going to pretend that we haven't seen it before. And just from our previous studies in algebra, we might remember that the equation of a circle is given by this equation. And you can see it's a circle with center HK with radius R is given by that particular form. Okay, when we talk about the unit circle, and you can see a diagram below, a unit circle is going to be a circle whose center is at the origin, so H and K are 0, right? So this is H, this is K, both 0. Okay, so adapt that equation as needed. And it has a radius that is unit length. When we use that language of unit in math means 1. Okay, so its radius is 1. Okay, and that's what the parenthesis says. Okay, and so then our equation reduces nicely, and this is the equation of our unit circle. X squared plus y squared is equal to 1. I'm going to see that over and over and over, so get that into your brain, okay? And so geometrically, we can see that equation expressed below. So we have the origin right smack dab in the middle, and then we go out a distance of 1 in every direction. And we could even go out, diagonally, okay? So from the origin, out is always a distance of 1, okay? And so you can see that the intersection of the circle and the axes are labeled so 1, 0, 0, 1, negative 1, 0, 0, negative 1, right? Why does this make sense? Because we go a distance of 1 from the origin, right? So that's fine. Those are 4 nice points on the unit circle. We will be using those very frequently. Okay, so again, something to commit to memory. But then the question arises, how do we find other points on this circle? Okay, and so that's what we want to explore in our first example. Okay, suppose we have a point P. We know that point P is on the unit circle, and it has this particular property, that its y value is 2/5. We want to find the x coordinate. Okay, well, how do we do this? Sit and think, cry a little bit, and then we remember that x squared plus y squared is equal to 1 is the equation of the unit circle. Great, and we happen to know what y is. Okay, x squared plus, and then we're going to substitute in 2/5, and then make sure to square that is equal to 1, and review algebra as needed, but exponents would go to both the numerator and the denominator. So we'd have 4 over 25 is equal to 1. Okay, x squared, move that over, so we get is equal to 1 minus 4 over 25, and we do not need a calculator for this because we are awesome mathematicians. Common denominator would be 25 over 25. So then subtract, we get 21 over 25, and then we cry a little bit because, oh goodness, 21 is not a nice square root, but that's okay. We can still say x is equal to, so we would, introduce a square root on both sides, and we would get square root of 21 over, I'll write it like this, square root of 21 over 25, and then simplify, so we can square root the numerator and denominator independently, and so we'd get square root of 21 over 5, and square root of 21 doesn't really break down that much. 3 and 7 they're prime, so we can't do much. Okay, and that is not our final answer. Okay, I lied to you a little bit, and I will do that frequently. Because I want you to catch things. I want you to tell me that things are wrong, right? And so the place that we went wrong was right in this step, second to last step. When you introduce a square root, you need the plus and minus. Okay, I'm going to repeat that and you're going to write it down. When you introduce a square root, you need the plus and minus. Okay, and it is okay to have the or multiple answers for each of these. Okay, so we found the x coordinate. That was our task in this exercise, and we are done. So just to review what we did, we started with the equation of the unit circle, used the given information of y is equal to 2/5, substituted that in, follow that through with the arithmetic, and we got our answer, remembering that when we introduce a square root, we need a plus and a minus. And so if we were to go further, right, what we actually found is a point on the unit circle, right? We use a unit circle to say, okay, y is this, and then we found x. So we could actually say that the point, or the points rather, if we do separate them into 2, square root of 21 over 5, comma 2/5, and negative square root of 21 over 5, comma 2/5. Those are both points on the unit circle. Great, we found a couple. Let's find them all. Yeah, there's definitely many. Let's not do that. But these points that we find on the unit circle, we call those trigonometric points. Okay, and this is a key bit of language, so really take your time with this. Okay, so we say, let's just kind of go through the definition bit by bit. Point P of t, okay, we don't know what t is, but that's an xy coordinate, is a point on the unit circle, and we call that point a trigonometric point if we start at the point 1, 0, on the unit circle and then move to this point, counterclockwise, a distance of t. Oh, okay, that's what t is. T is a distance along the unit circle. T is an arc length. Okay. Oops. T is an arc length. Okay, let's keep that in mind. So we move from 1, 0 to t, or to p of t, a distance of t, counterclockwise if t is non-negative, and then if we have t is negative, if the arc length is negative, again, that's going clockwise. Okay. So, okay, great. I found, in the previous example, we found xy, right? How do I find t? This is where we have to remember that since t is an arc length, we have the equation, we had that equation s is equal to r theta, and this was our arc length, right? So now we're just using a different variable. Okay, fine. T is equal to r times theta. Okay, and on the unit circle, r is equal to 1, right? It's a, I'm going to say on unit circle, because the unit circle is has a radius that is unit length, radius of 1. Okay, so I can just say t is equal to 1 times theta, so t is equal to theta, right? Be careful. What were the conditions on theta? Okay, theta is in radians. Okay, so when we talk about t, we can actually just say it's the angle from the unit circle that we're working with expressed in radians. Okay, so easy way to find t if need be. All right, so concluding example here. Find the compass points from the unit circle. Compass points, I'm talking like north, south, west, and east. So find those points on the unit circle as trigonometric points. So we want to express them in the form of P of t is equal to x, y. Okay, and so really we need to find t, we need to find x, we need to find y. Okay, let's start with one at the east. Okay, so P of something, and we already have the point as 1, 0. The question is, what is t? What's the arc length? Okay, and well, and maybe a better question is, since t is equal to theta, what's the angle in radians there? 0. You could also say it's P of 2 pi, right? If you go one full rotation around. Okay, that works. Let's do west next. Okay, P of something is equal to negative 1, 0. Okay, how far is it to get to this point? Well, if we remember our angles, right, we go, half a rotation around the circle, that would be pi, okay? And so I want you to pause video, do north and south, find those trigonometric points, and resume the video when you're ready. And there you go. You got p of pi over 2 up at the north compass point, and then at the south compass point, it'd be p of 3 pi over 2. Okay? So we have at least, here we have 4, and in the previous example, we found another couple points that are on the unit circle as trigonometric points. All right? We'll develop some more points along the way.